Welcome, everyone, to 5 Ways to Capture More Value Through Smarter Machine Design, presented by Guide Automation. My name is Kimberly Leaders, and I'm with Modus Labs, who is the sponsor of this webinar. Guide Automation is an authorized partner of Modus Labs. Modus Labs provides a new line of innovative geared solutions for robotics and motion control. Before we begin, if you have a question, please enter it in the Q&A section, not the chat area. We will address questions at the end. Now I'd like to turn it over to Joe Romine. Joe?
Thank you, Kimberly. Good afternoon, everyone. My name is Joe Romine, and I'm the founder and president of Guide Automation. At Guide Automation, our goal is to partner with our customers and their engineering teams to build better machines through smart machine design. This may mean increased throughput, higher precision, greater reliability, and yes, even lower cost, or an increase in overall value, as we will discuss in this webinar. If you have a new machine design, we can help with component selection and sizing. We can also take a look at your existing designs to see where improvements can be made. But what really sets us apart is our ability to work with your team to find value and add value in areas you may not have thought to look. That's what we will discuss today. We partner with some of the best manufacturers in the industry, and we are always keeping an eye out for new, innovative products to ensure our customers have the cutting edge they need to succeed. One such innovative manufacturer is Modus Labs, our sponsor today. Modus Labs came up with a rather revolutionary gearing design. This new gearing architecture shown here is unique. It's a zero backlash gearing solution with high precision and torque density, zero backlash, and smaller physical size and weight. What does this mean? It means for the same torque output, the Modus gearbox weighs much less than competitive technologies. In a robotic arm, for example, this means that less torque is required in the preceding joint. This results in smaller and lighter motor gearbox, and the cycle continues down the arm in each joint. Thus, your entire robot weighs less and uses smaller and less costly components. This means more value as well as a competitive advantage. A big thank you to Modus Labs for sponsoring this event today. Okay, now on to the slide you have all been waiting for, cost reduction. Everyone is interested in reducing cost. And don't get me wrong, cost is very important. Reducing overall machine cost can mean the difference between winning a new sale or losing to the competition. But often, cost reduction is viewed from a component level. How can we get a discount on this part or that part? This approach may work in the short term, but it isn't an effective long-term strategy. Motors, amplifiers, gearboxes, bearings, motion controllers, all these items have a real manufacturing cost. And as raw material costs increase, manufacturers are getting squeezed from both ends. There's only so much room to move. I remember one project I worked on where the purchasing team required a 5% cost reduction on parts every single year. Obviously, that wasn't possible. You can't do that. And so what we did is with that customer, we did exactly what we're going to talk about in this presentation, and we looked at the problem from a different point of view. So how can we use this strategy to help you? Well, we can achieve the same goal of lowering overall machine costs by looking at the problem from a value perspective. When working with our customers on a new machine design, or when looking for ways to add value to an existing design, we typically focus on the 5 key areas listed here. At the end of the day, adding value in these areas will directly reduce your overall machine cost, manufacturing headaches, and field service calls. Your machine build process will be streamlined, and your customers will have a better experience using your equipment. Adding value in these areas results in a win-win situation for everyone involved. Now, let's dive a little deeper into each of these areas to discuss the specific tips and tricks we can use to find more value. First is reducing assembly time. Man hours are often the largest expense when designing and manufacturing a machine. So, if we reduce the time spent building a machine or troubleshooting the assembly process, we reduce the machine cost. How can we do this? Look for parts of the machine that can arrive pre-assembled, or look for components that integrate multiple parts. For example, you see two pictures here showing a motor that has integrated amplifier electronics. If the amplifier is integrated as part of the motor, that's one less item your technicians need to install. It also eliminates any cabling that would have been run between the motor and the amplifier. And as we'll discuss later, eliminating cabling reduces troubleshooting time and failure points. Sometimes the amplifier cannot be integrated into the motor because of the power required. In this case, look for motor amplifier combinations with reduced cabling. You see the image of the Kollmorgen motor and amplifier with the orange cable. This design has a single cable that carries both the motor power wiring as well as the feedback signals. Also, take a look at the machine design from a mechanical perspective. Are there mechanical components that can be combined or eliminated? Here you see examples of integrating gearing inside the wheel of an AGV, and a screw integrated as part of the shaft of a motor. Another area to consider, pre-configured electronics. Your HMIs, PLCs, motion controllers, amplifiers, all of these likely need to be configured via software before they're installed. Often, we can work with suppliers so that these items arrive with a software file pre-installed. This saves your assembly team a step, and it reduces the likelihood of issues because the wrong configuration was installed. Using the right technology. Automation technology continues to evolve and advance, and some of these innovations can be game changers. We already mentioned Motus Labs gearing technology and how that can result in reducing the power requirement of motors and amplifiers across your machine. This is one example of using the right technology. Another technology to take advantage of is communication buses, a method for transmitting essential data between devices. There's a bunch of different communication buses out there: CAN-open, Ethernet IP, Modbus, Profinet, PowerLink, the list goes on. But we usually recommend looking at EtherCAT. The EtherCAT communication bus allows for simple communication between devices using a standard off-the-shelf Ethernet cable. As more and more manufacturers add EtherCAT support, the technology is becoming much easier to implement. Regardless of the communication bus you select, this technology reduces wiring and assembly time. It also allows for the transmission of additional machine status data. This data, including faults and warnings, helps to quickly identify and resolve problems, resulting in greater machine uptime. Also, critically important machine design consideration is motor selection. With so many different motor types, how do you choose? This is a difficult question to answer in a 30-minute presentation, but it's one that you have to get right. Selecting the wrong motor technology can mean hundreds of dollars wasted on extra performance that you don't really need, or on a motor that doesn't quite do what you need it to. For example, maybe you have an application that requires relatively slow speed and doesn't need to be very smooth or precise. A servo motor could do this, no problem. But a stepper motor is designed to provide high torque at low speeds. A stepper also costs less than a servo, and it doesn't require a feedback device, and the control architecture is much simpler. So, if you choose servo, your machine will certainly have the performance you require, but you may be paying for a technology you don't really need or aren't even using. Correct component sizing. The critical point here is the one in red. Simply put, if your motor is oversized, you're paying more than you need for the motor, gearbox, amplifier, cables, and power supply. Often, when designing a new machine, engineers calculate theoretical loads, torques, speeds, and friction. Then, a safety factor is added on top of those numbers to make sure the selected equipment will do the job. Because of this conservative sizing strategy, it's common to find a motor on a prototype or existing production machine that's twice as large as it needs to be. As you can imagine, the cost of this oversized equipment can really add up. So how can we help? For servo systems, Guide Automation works with our customers to take measurements of actual torque and speed requirements. These measurements are taken on a prototype machine or production machine during normal operation and compared to the theoretical calculations as well as the manufacturer's rating. Often, it's possible to reduce the size of the motors, drives, and amplifiers so you're only paying for what you need. We have mentioned cables a few times so far. Cabling can often be the source of costly headaches. When two devices need to share information, they're normally connected using physical wires. Generally, the more information you need to transmit, the more wires you need. If the information is coming from a sensor, or if the information is being transmitted between devices from different manufacturers, it's common to wire these signals by hand to screw terminals. The image here shows a typical electrical panel with a typical row of screw terminal connections. Screw terminals make it easy to connect one device to another, but they can often be problematic. Sometimes the screws aren't torqued properly and don't make a good connection. And sometimes a wire is terminated to the wrong screw terminal. You can imagine how easy it would be to place one of these wires in the wrong terminal. If that mistake is made, the equipment on either end of that wire can be seriously damaged, resulting in delays and costly repairs. There's one customer that I visited that was complaining of the machine wasn't working, the motors weren't moving right, they were getting all these faults and warnings, and I go up there to find just a rat's nest of wires inside this electrical panel. Nothing was shielded, nothing was routed. It was hard to determine what wire was going from one place to another, and so we found out that the problem was due to coupling between noise from one wire to the other, and that was because of how they had these cables set up in the electrical panel. So anytime that we can reduce or eliminate cabling and use an off-the-shelf shielded cable, that's something that we want to do. It's very important to eliminate hand wiring wherever possible and to use proper shielded cables and good cable routing techniques when assembling an electrical panel. How can we help with this? Well, Guide Automation works with our customers to create custom interface modules. While it's not always feasible to eliminate all screw terminals, they can often be greatly reduced. When creating a custom interface module, our goal is to use a standard off-the-shelf cable, as seen on the left, to replace as many screw terminal connections as possible. That way, when assembling a machine, the technician only needs to connect a standard cable from each device to the interconnect board. This greatly reduces the chance of human error, and it also reduces the time needed to assemble a machine. You can see here a few examples of interface boards we have designed. The smallest one on the left is used to make a serial communications connection between a PC and a servo amplifier. The board in the middle eliminates the need for custom cable by making all the required connections on the board. You can also see there are a few necessary screw terminals, and these are clearly labeled to further reduce the possibility of human error. And on the right is an interface board with added functionality. This interface board has been designed with a simple PLC to control and monitor some of the inputs and outputs. This single board takes the place of custom cables, power supply, and the PLC. Combining this functionality reduced the overall machine costs and the machine installation time. Guide automation also has the ability to help with customized PCB mounting cards for servo or stepper amplifiers. Normally, a panel mount amplifier is used like the one on the left. This amplifier would be physically mounted in an electrical panel. Then, custom cable assemblies would need to be made to connect sensors, feedback, communication, regenerative braking, resistors, and other equipment. With a PCB mounted amplifier, a customized PCB is designed to accept signals using standard off-the-shelf cables. The amplifier then fits into the corresponding connectors on the PCB. This plug-and-play design makes for quick, streamlined, and trouble-free assembly. Lastly, I wanted to mention special terms and agreements. At the beginning of the webinar, I implied that purchasing departments often approach distributors and manufacturers asking for a 5% cost reduction or a discount on a part. I suggested that this isn't the most effective approach and that looking for areas to add value would be much more effective. So far, we have discussed areas where engineers and machine designers can capture more value. But I want to be clear that purchasers have a role to play too. And sometimes it helps to get creative and think outside the box. A few examples: extended blanket orders. Sometimes when designing a new machine, you may only need 10 units of a part for the prototype. Then, in the second year, you see production taking off, and your project's need will be in the hundreds. The problem? The 10-piece price is 3 times the 100-piece price. How can we help? Guide Automation works with our customers to set up detailed agreements tailored to each customer and their unique situation. In this case, we may set up a 110-piece blanket order that would be taken over the course of 2 years instead of the typical 1. That way, the 100-piece price can apply even to prototype builds. Payment terms. Each customer and each situation is different. The industry standard payment terms are net 30 days, but maybe your manufacturing cycle takes longer than this. Maybe 60 days fits better with your situation. In these situations, we work with our customers on special payment agreements. This directly adds value by saving on financing costs associated with machine builds. Finally, something that has become somewhat of a bad word in the industry today: stocking. If you haven't noticed, nobody stocks anything anymore, and it has become a problem. Need I mention the words chip shortage? If you can't get products, you can't build machines. So how can we help? Guide Automation can stock products for you where it makes sense. If you are constantly dealing with delivery issues from your existing suppliers, reach out to us to discuss a stocking agreement. That way, when you need a product, it's here. This reduces or eliminates manufacturing delays, saving you time and money. So, to wrap things up, the most effective way to reduce total machine cost is by taking a look at the machine design to reduce assembly time, ensure the right technology and equipment is being used, eliminating cabling where possible, and getting creative with purchasing terms and agreements. I wanted to thank you all for joining the webinar today. If anyone has any questions, we'll be taking those now via the Q&A section, not the chat window. Happy to answer any questions you might have, and I will turn it back over to Kimberly, who will lead the Q&A section.
Okay, Joe, you can advance the slide one. That would be great. Just advance. There we go. Okay, we do have a question. Mark wants to know, what about wireless communications? I believe he put this question in when you were on the slide where you were talking about the right technology. If Mark wants to write in anything more, that would be great, but I think that's what he asked.
Yeah, I think you just broke up just a little bit. I think the question was wireless communication. Is that right?
That's correct. He just says, what about wireless communications? And he wrote that question in on the slide where you talked about using, making sure that you're using the right technology or, innovation.
Sure,
and so on and so forth. Okay.
Yeah, so wireless communication is certainly up and coming, and it's something that I am keeping a close eye on, as well as a lot of my colleagues. It's not quite, in my opinion, ready for prime time yet. I think there's still some kinks and some bugs to work out, similar to the bugs you experience when trying to connect your phone or your computer to the internet. Sometimes that connection just doesn't quite work the way you need it to, or sometimes there's interference and you lose the connection. So the industry, we really want to make sure that that is robust and proven before we roll that out to the field. So I think that it's going to be an important technology moving forward, but I don't think we're just quite there yet.
Okay, he just added to the question. He meant to say, over extended distances in hazardous environments, are there standards like Bluetooth or wireless data?
Yeah, I do to kind of elaborate on, we're not quite there yet. I do think there are some of those sites. I don't have any projects, particularly in hazardous environments right now that I'm working on, but I do think that's some of the sites that this is being rolled out on because it is necessary, and so even if it doesn't work quite the way that we'd like it to, maybe there's a few bugs, it's worth it for those environments. So I think that's where the technology is starting, and then as it becomes more robust, we'll roll it out a little bit further in the industry. And so hopefully that answered the question.
Okay, the second question is, why do you recommend EtherCAT over other communication buses?
Yeah, that's a good question. So there's a whole bunch of different communication buses out there. Could do an entire presentation just on that. They all have advantages and disadvantages, but I like EtherCAT because it's not proprietary like some of them, and it's being more and more widely accepted in the industry, and more devices are supporting EtherCAT over others. And so that really makes it easy to implement on a machine when all of the devices speak the same language. Another advantage is that it's deterministic. And so if you're trying to do something that's time critical, or you're trying to do something that involves coordinated motion, this kind of a technology really does matter. You do need a deterministic bus to make that kind of motion happen.
Okay, another question is, what is the typical cost and lead time on a custom interface board?
Sure. So it's really, of course, not necessarily the answer you want to hear, but it's going to depend on what it is and what the project is. How many cables are we connecting to the interface board? But just to give a couple examples, there was the very small one that I showed you in the presentation. Something like that, might cost a couple $100 in development, and maybe $10, $15 per piece. Of course, it depends on the quantity being purchased as well, highly affects the cost. For a medium or a kind of maybe the larger PLC type of board that we saw, that one may cost a couple $1,000s to develop, and maybe $250 each. Again, depending on the quantity ordered. So that gives you a kind of a ballpark price, and lead time on those could be maybe a month or 2 months to develop, and then another month to actually get it fabricated and delivered.
Okay, the next question is, have you ever used HDPLC, power line communication, within an application?
It was HDPLC?
Yeah, HD-PLC, power line communication
No, I
within an
can't.
app.
I have not run into that yet. So I have not used that technology yet, but will look into that and can get back to you on it.
Okay. Another question is, that circuit board mounted amplifier doesn't look as secure as the panel mount. How does the amplifier stay connected to the board?
Sure. Yeah, that's a common question. It obviously doesn't look as robust as the bigger one that you would kind of bolt to an electrical panel. But with that being said, it is a robust and proven solution. That particular manufacturer, the one that was shown, is Copley Controls, and they actually have a ruggedized version of that PCB mount drive that's used in military applications. And so the military has vetted it. If you look closely enough, you'll see most of these PCB mount amplifiers have an area for screws that actually go through the drive itself and then through the PCB to fasten and secure it to the PCB so it won't come out of that mounting area.
Okay, that ends all the questions at this time. I'd like to just mention to everyone out there that you are welcome to contact Guide Automation for any further questions. Any other comments, Joe?
Nope, and that's all I've got. I'd like to say another big thank you to Modus Labs for sponsoring the webinar today. And you can check out their gear solutions at modus-labs.com.
Okay, great. We will be sending out this recording later today. And I just want to say this concludes our webinar for today. And I'd like to thank everyone for attending, and have a nice week.